VMware.com vBrownbag US edition. Tonight our guest is Jeff Carrell. He is at Jeff Carrell _V6, and he's going to be talking about IPv6 and Wireshark. My name is Damian Carlson. I'm 6 foot out on Twitter. I've got a host riding shotgun with me tonight. That is Ahmad Yunus. He is at Ahmad _Yunus. I'm sure you should be able to see that here on the screen. If not, let me know. So yeah, a few notes before we get started. We are planning 2 more editions of our vBrownbag Tech Talks. If you've been around the show for a while or run into us at various VMworlds, you know that we, for the past, golly, maybe 4 or 5 VMworlds, I could be totally misremembering, but for the past few VMworlds, both US and in Europe, we've had stages set up within the community hang space and have had a very packed schedule of tech talks that go on all day, every day of the conference. So we are planning on doing the same thing at VMworld Europe, as well as at OpenStack Summit in Paris. So fingers crossed for me that I get my travel expenses approved for both of those. So feel free to jump in on the conversation either through the Twitter account at vBrownbag with the hashtag vBrownbag, or even by submitting a question through the webinar interface. So, of course, we do this every Wednesday night at 7:30 Central. We also have Asia Pacific, which runs every other Thursday, EMEA on Tuesdays, and Latin America Spanish-speaking podcasts on Thursdays. You can always go to professionalvmware.com and register for any of the additional podcasts as you'd like. Check out the Tech Talk schedule, etc. So, without further ado, Jeff, I'll go ahead and hand the reins over to you if you'd like to introduce yourself, and then we'll get going.
Great. Well, thanks very much. I appreciate the opportunity to be again back on Virtual Brown Bag, and thanks everybody for taking the time out of your evening or your day, whichever part of your day it is. But we certainly appreciate that. We're going to talk about IPv6 briefly tonight, as well as Wireshark, and basically it's IPv6 inside of Wireshark. So let me bring up a screen here so we can start going. I've been in networking a long time, and long time means I built my first network in 1986, and kind of been doing networking ever since, and started playing with IPv6 about 4.5 years ago. Been playing with Wireshark in its predecessor's name of Ethereal, or as we would pronounce it in Texas, Etherreal, for basically ever since its inception, and played with lots of other protocol analyzers. And pretty much thought it would be a nice thing to help folks that are just kind of getting into their IPv6 knowledge train and see how it looks a little bit inside of Wireshark. And it's not that this is anything magic or new, but it's hopefully to point out a few things that you can, I'll say, tune your Wireshark when you want to look at some IPv6 specifics when you're trying to, go through all the packets that are floating on that network segment, and just kind of see how it goes. So let me bring up my session here. The slideshow, there we go. So there's a little bit of contact information you'll be able to see. Twitter handle, always feel free. I had some tweets even after the session I did last week, and the other information. So again, I'm going to do a little bit of IPv6, not the same 2 hours worth I did last week, and if you need to go back and refer to that, or if you missed it, weren't able to attend, it's now up and available. You'll be able to find that link at the Brown Bags link. It's a little bit further down there on that page, and you can go get that podcast and listen to it. So I'm going to do what I call IPv6 briefly, and it's going to be really fast, really high-level components of IPv6. Again, if you need a little bit more information, you certainly can refer back to that podcast or all kinds of other v6 references, and I'll even have a few of those for you. And then I'm going to cover a little bit about Wireshark. I call it basics. It's actually like 1 or 2 slides. and I'm going to dive right into some components of Wireshark that I find a lot of people don't necessarily use as much as they might could. It just depends on how much you actually do use Wireshark and get into it. But I'm going to very specifically talk about coloring rules and display filters, columns and configuration profiles, because this is part of the power of Wireshark, and being able to have Wireshark, I would call it multiple configurations to help you use that tool in order to find the things you're trying to find with all those packets flying around. So that's kind of our plan today. So briefly, it's just going to be basic IPv6, basic information, auto configuration, and just a quick touch on DHCPv6 and DNS, because there's certainly some differences in those operations as compared to IPv4. So if you attended the podcast I did last week, or any of the other type IPv6 training sessions, this next little bit will be a refresher for you, perhaps for some folks, though, if you haven't played with it at all. It's going to be, I'll call it the quick tease. And so we've got just a little bit of these little bullets. Every v6 presentation and talk has to have something like this that basically says v4 that you know of today, or IPv4 that you know today, has about 4.3 million addresses, or excuse me, billion addresses. And IPv6 has 340 undecillion. And undecillion is not a made-up name or a made-up word, but it's just unfathomable, really. Or incomprehensible almost, because it's just such a huge number. But the bottom line is, from an addressing standpoint and an address allocation standpoint, the theory is we will never run out of addresses. So that's kind of the key thing to know about it. It's just a big, huge number that we will have address capability for multiple lifetimes, I expect. So we know the bit about 32-bit IPv4 addresses, 128-bit v6 addresses. Should understand one of the key things about IPv6 is it uses hexadecimal numbering as opposed to just straight decimal. Now, if you've been in networking for, I would say, 15+ years, quite possibly you've been exposed to hexadecimal addressing systems such as Novell's IPX SPX or Apple's AppleTalk. Those were kind of the key ones throughout the middle late 80s up through probably about the late 90s, and then you pretty much started seeing those two protocols sunsetted out of networks. But if you remember that, we're kind of back to the mode of we can spell words inside of our networking address structure. Probably one of the other biggest changes is, and it's not so much a change that I would say is hard, it's just that it's hard from a typing standpoint, where we use colons as the delimiter between groups of numbers inside of an IPv6 address, which is coming up here in just a minute, as opposed to using the dot, or as our friends and family would say, that period, that 192 period 168 number. So with this 128-bit number, it is broken up into 8 sections with 16 bits in each, and then delimited with a colon in between each of the 8. Now, the kind of official designation of these sections of each 16-bit address blocks or address components actually is still kind of up in the air. There's an RFC that kind of has the most favorited ones here, kind of at the very end of that string where it says the hexadectet. That's considered the most numerically or mathematically correct term, but it's kind of a hard word to say, and if you're from the South, and we have to add extra syllables, and so hexadectet gets to be sometimes a little hard. Hextet is becoming a little bit more popular. Chunks was fairly popular. I've done quads as well, so just pick a number. The hextet seems to be kind of winning. Hextet, octet from the old IPv4 day, that's still work out. But as you can see, this address example that I've got down here, 2001 colon 0db8 and on, but you can start to see little words in there. I've got 6lab, foosball, you'll see Facebook's in an example later on, all kinds of words that you can kind of spell with a hexadecimal numbering system. However, you really shouldn't do that from a production standpoint, because that's what, quote, the bad guys are going to be looking for. When they're out there doing their surveys, they're going to be looking for common words like that. So it's okay to be fun. It's okay to do it in maybe a lab or on an isolated network, but you probably really don't want to do it in a production world. Now with the 128-bit address, the key bit is a lot of people think that that's a lot of number, a lot of stuff I'm going to have to memorize. Oh, it's going to be too hard. I don't want to do this. And there's tons and tons and tons of excuses. But the key about it is that the default operation or the default assigning of an IPv6 address is effectively 64 bits are reserved for the network component, and 64 bits are reserved for what's known as the interface ID or node ID, or what we would probably more commonly know as the host ID. And that's the default, and that's the way a lot of operating systems work. That's the way some of the applications work. And if you literally try to change that concept of a /64, kind of in the CIDR notation, the /64 representing the network bits, 64 bits of network ID. If you don't change that from a standard VLAN type network or endpoint network, everything will work if you just leave it alone. And a lot of people say, well, I need more network bits. And it's like, if you need more network bits, that's, you got to do something different. You got to get a different prefix assignment from either your provider or from your regional internet registry. But for the most part, follow this plan. It's just the easiest thing to do. Think of every network that you would have devices on to be a 64-bit network prefix. And then you have 64 bits of host ID to play with from either an automatic viewpoint or a manual assignment viewpoint. And I'll talk about those in just a minute. And the cool thing about it is 1/64 network is 4 times the size of the IPv4 space collectively. So a lot of people get hung up with this. I'm going to have 18 billion possible addresses on my VLAN. I'm only going to have 200 devices because I'm not re-architecting my physical layer network. And okay, fine. That just means you have a lot of capability to have some really creative addressing down there at the interface ID level to make it a little bit harder to be scanned, etc. Now an IP address, IPv6 address, when broken out, and we're going to use that middle number down here, this middle example number, may have zeros in it. It could be multiple hextets of zeros. You may have leading zeros, as you see there at the 4th group. And in the IPv6 numbering system, we have a couple of shortcut options. They call them shorthand notation. You can drop leading zeros, and then you can also group up multiple groupings of zeros to what's called the double colon. So if you look at option 1 up here, I've got 2001 : A52 : 0, 316. So that first double colon you see took care of the second and the third hextets worth of zeros, and then I dropped that leading zero out of the 4th. Now, the deal is you can only do the double colon once inside of an V6 address. You cannot do it twice. And it should be relatively obvious, but I've got a good example of that here coming up in just a second. So in the 5th, 6th, and 7th hextet, I had to still leave a value there, and in this case I dropped the 3 leading zeros and still left a zero, a single zero. So this is in option 1, a correctly usable IPv6 address. Now option 2 down at the bottom, I chose instead of taking the 2nd and 3rd hextets and reducing it down to the double colon, to instead use the 5th, 6th, and 7th hextets and reduce it. So you can see 2001 : 0, A52 : 3D16. So from a perspective of use and validity and most importantly test questions, all 3 of these representations of an IPv6 address are valid and accurate and usable. All right? So you could enter in longhand, you can enter in whatever shorthand options that you have. The considered best use of the shorthand notation is the shorthand that gives you the most reduction. So in that case, option 2 would be the more correct use of shorthand notation because it reduced down 3 hextets of all zeros, where option 1 reduced down only 2. So you have to also kind of go from that perspective. I'll call it from a test question view. The most reduction is the best answer, but all three of those are good. And that's contrasted by this example where I took the longhand notation and shortened it, but I did it with 2 double colons. You can't do that. You're not supposed to do that. You shouldn't even be able, in any operating system, be able to do that, because it's invalid, meaning how many bits are at that first double colon and how many bits are at the second double colon. Because right now you can actually use a double colon for just one grouping, one hextet of zeros. It's not considered the best practice, but it's not an invalid practice. Right now it's at the RFC is at an informational state. It's not at an approved state. So this would be an incorrect representation on any test question. This one down here in the middle with the 2 sets of double colons. That's kind of a period, end of story. So only use double colons once. I've not found any operating systems, client, server, or infrastructure operating systems that will even allow me to do that, much less can I get away with it. So part of IPv6's overall design concept is, and one thing to kind of understand about v6 is that the whole concept started back in late '92 of a new numbering system. In 1992, we didn't have NAT, we didn't have DHCP, we didn't have RFC 1918. Everything was hand entered. And part of the whole concept of v6 was we want some automagic capability. And you're going to see some more of this here coming up in just a minute. Part of that auto component was auto configuration at a client level with only routers on your network. And routers will give you your network prefix. The client will self-derive its interface ID. The first concept is how do you self-derive an interface ID from nothing? And the designer said, well, we've got interface card, so it means we've got a MAC address. Oh, but it's 48-bit. There's an existing IEEE standard known as the UE64 that says take a 48-bit MAC address and insert FFFE in the middle as padding to now make a 64-bit address. However, the v6 team decided that, well, we want it to be a slightly more unique number than just the UE64, so they added the component of taking the 7th bit of the first byte, known as the local global bit, and invert it. And now you have a modified UE64 64-bit address, and that would be used as your interface ID. There's the 64 bits for the interface ID. And it would be more uniquely known for an IPv6 address. However, about the mid-2000s, it was kind of decided by a few entities, Microsoft leading the charge, that they wanted something that was a little bit less predictable, a little bit more random, a little bit more unique. And so they spearheaded an RFC to, instead of using the MAC address as the foundation, to come up with a, quote, random 64-bit generated number. And it's been ratified, everybody's doing it, and now either one of those options, using a MAC address as the foundation or a random number generator for the foundation of the number, is a valid way to do these things. So we have this as an option. Fundamentally, the process creates this random 64-bit number, and then there's actually a second number generated, or could be generated, and it's known as the temporary address. And the temporary is actually an address that should change on some periodic basis. It's left up to the vendors, and that would actually be the address used for outbound communications, as it would be considered a unique number. And because it would change on some periodic basis, it would continue to be unique, and people can be found and refound because it's not a statically assigned address. So we have those couple of options. You'll see some examples of these coming up in the Wireshark trace stuff. So a couple of comparisons between the v6 and the v4 world, just to help with the knowledge understanding. More than anything else, from an address type, in IPv6, there is no broadcast type address in communications. Everything that you know to be a broadcast type message in v4 is now a multicast on-link type message. So it's actually, I would say, a little bit easier to deal with, because now if you're not communicating locally with a known number, then anything else that you want to do on-link or across a link through a router link is a multicast message. So it makes it a little bit easier to troubleshoot and go through and understand all that. Kind of understanding kind of the scope and definition, it's a little bit different in v6 from v4 from the aspect of you will have multiple IPv6 addresses on an interface. And if you've got multiple interfaces, they will all have multiple IPv6 addresses. You will always have one called the link local. Its most closest analogy is likened to the v4 APIPA address. The change is, in IPv4, you lose the APIPA address when either you manually assign a v4 address or you dynamically through DHCP assign. In the case of v6, you will always have the link local. You will always. If you get an assignment through a manual or some other automatic method, you will then now have two addresses. In the v4 world, we're very much used to playing with a private address, the RFC 1918 type addresses, and there is a similar counterpart in the v6 world. They call it the unique local, and it's got its own assigned address block. But because there's no NAT technology in IPv4, then there's really no way to route off of a private address block. There are some entities that do make routing functions or NAT from the unique local to the kind of like public addresses, but that's not considered an official v6 technology, as it were. But there is references, and there's lots of information about unique local addressing in the v6 world. Basically, if you need something for a secret squirrel lab or whatever, do it. Otherwise, don't use unique local. Just stick with what's called the global unicast, which is a routable on or off your environment. Now, we have some reserved addresses in the v6 world, and it's actually much easier because they're within different address assignment blocks. So unlike IPv4, where everything is carved out of that entire address block in bits and pieces here and there, in the v6 world it's really, really easy. All of your link local addresses, as you kind of see about the middle of the slide there, come from a block known as FE80 :/10 area. All of your routable addresses for IPv6 right now will be from a 2,000 or 3,000 block. They've carved out about, an eighth of the current total 340 undecillion addresses, and that's what we have represented right now. We haven't even begun to scratch that surface. That unique local I was talking about has got a reserved range. We've got this reserved documentation / example range. Most of us never really did that in the v4 world. We pretty much always used like RFC 1918 type addresses. But in v6, there's an official address block to be used. My most favorite of all is the loopback address. If you've ever seen those T-shirts or mugs or whatever that said, 127.0.0.1 suite, 127.0.0.1, the home sweet home. Now it's really cool because it's just : :1 suite : :1 home sweet home. So fun stuff with v6. It just continues on more and more as we go through. A few more things here. In the v6 world compared to the the v4 world, we have another timer as far as how long the IPv6 address is valid to be used. In a v4 world, there was actually a valid lifetime timer, but it was typically either infinite for the APIPA address or days, weeks, months if it was manually automatically assigned like through DHCP. Manual addresses typically had an infinite lifetime. In the v6 world, part of the other components for it was they wanted a way to readdress networks. And if you've ever readdressed an IPv4 network, you know how hard it is. You send out the email on Friday and tell everybody to shut off their computers. You're going to be redoing the network. You come in Monday and everything will be fine. And then when you come in Monday, half the people never saw the email or didn't turn off their computer, or you found a whole room full of gear that you didn't know existed. And so to readdress the network was relatively hard. I mean, it was an exercise. In v6, if it's using all the proper design constraints and automatic addressing as opposed to, say, static, then this timer environment, the lifetimes, actually work to your advantage, because now you have this what's known as preferred timer and a valid lifetime timer. And the preferred means do everything you need to do, start communications, continue communications with that timing. When the preferred lifetime expires, the address is still good from a aspect of valid lifetime to finish up existing business. But any new business would have to be on a new generated address or an updated preferred lifetime timer. So this gives you that capability in this automatic use of v6 addressing to tell devices, hey, your timers are now shorter and now you're going to get new network addressing, and your new communications will start on the new network, all your old communications will finish on the old network address, and life is great, and it works really, really, really well. So you literally can readdress very large networks with a lot less effort than we've ever had to before. So it's just kind of understanding that we have a couple of timers here and how they're used, and you will actually be able to see some of that information as well. When we think about neighbor discovery information between v4 and v6, this is just kind of a quick bit to understand the naming convention. A very important key point for v6, everything you know about v4 has a counterpart in v6, but 50% of the time they're called something different, or they're operating slightly different. And then there's other new things in v6 that v4's never, ever, ever had. So this just kind of gives you a little bit of the comparison. All of these functions now from this kind of neighbor discovery protocol and usage is under the context and the functionality known as the IPv6 neighbor discovery protocol. And so all these break down into one group, as opposed to in the v4 world, some of these operations were split around different RFCs, if nothing else, where the neighbor discovery protocols for IPv6 are all bundled into one RFC, so it makes it much, much easier to be tracking. So under this neighbor discovery protocol, you saw some of the things that it would do compared to v4. It's just basically how you find your neighbors, how you find your router, how you get addresses, how you keep track of neighbors, and all these kinds of things are part of this overall neighbor discovery protocol environment. These four particular neighbor discovery protocol ICMP-v6 message types are the key to v6 operation. And this is a key from multiple aspects. You cannot, on router interfaces and firewall interfaces, categorically block ICMP-v6. If you do, IPv6 will pretty much not work. And so you have to leave some open doors. You can do that. You can punch holes for the very specific types of ICMP-v6 messages that are required, but you can't just block it altogether. It just won't work. It just won't work. So these are the key ones we're going to be seeing some of tonight. Now, in the IPv6 address auto-configuration arena, the router is the key component in the infrastructure level. The router will send out some very specific message types, and we have seen those just a minute ago, known as the router advertisements. The router advertisements have components that tell clients how they will get their address. In this chart, basically if you go from the left side and go across, in order to use one of those particular functions means you have to set certain bits or certain flags on a router advertisement on a routed interface on any particular network segment. Now, if you're just doing link local, you'll need a router. Link local addresses can't be routed. They're only used on that local layer 2 domain, as it were. If you want to get off of that link into another network segment in your environment or to the outside world, then you need a routable address, you need a router, and you need router advertisements. This information is golden. You want this slide handy when you start playing with your v6, because it can be very challenging to get the right combination of flags. The manufacturer documents are really, really good at telling you what all the flags do, and this is how you turn the flag on or off. What they don't tell you is if you want a certain function like stateless address auto-configuration, SLAC, you have these bits on. If you want DHCP v6, known as stateful, address auto configuration, you need a couple of different bits set. And that's where people end up getting unfortunately tripped up sometimes, is that the manufacturers don't tell them, well, to do this you need to turn these off and these on in order to achieve these goals. So we'll see a little bit of this in operation here when we get into Wireshark. All right, a couple more things. DHCP v6 is fundamentally or operationally similar to v4, but there's different types of messages. If you're used to the DORA acronym in IPv4, we now have what's known as the SAR acronym for IPv6, DHCP v6 functions. First off, you have to find out if you've got a router. The router will tell you, yes, I'm here, and these are the bits set. Go ask for a DHCP v6 server, so you, as the client, will send out a solicit message saying, any servers around? Server will come back with an advertise. You'll say, can I have an address, please, and possibly my DNS and my domain name and my download server and my time server and my whatever else server I need, and the DHCP v6 server will give you a reply with all of the appropriate components that it can. So just a little bit to understand that that process is named different, but very similar in its operation. Another little component to reference, I think more people are understanding this one today, if not some of the other functions and capabilities of v6. In DNS world for v6, we now have a quad A record to represent a host name's v6 address, and so you can just see that. It's a quad A request to a DNS server. And then to see the reverse notation is my example down at the bottom there. It's a little bit different. We take every digit in a v6 address, which they're known as a nibble, and you work it backwards. So you can kind of see the ARPA.IP6.2.6.0.7 and on. You can see it's the v6 address backwards with a dot between every nibble in order to get your reverse pointer. So a little bit different. Kind of the key is your DNS server would have to support this, but most DNS servers within the last 5 to 6 years, have supported this capability, so it's not typically as much of a problem. All right, well that's my v6 little briefs. I'll call it about 30 minutes, so hopefully that helped a little bit. Again, you can certainly refer to lots of other information for additional details as we go. All right, let's play with Wireshark. Who's ready to play with Wireshark? We can actually do hands, and people can raise their hands. Anybody interested in doing that? Or at least I see we can do some hands. Anyway, we may not have the capabilities. I'll look over here at my client side. Well, that's all right. So Wireshark, I'm going to, I'll say, make the assumption that most network folks, or a lot of network folks, probably a better way to say, use Wireshark. If you use another protocol analyzer, mostly, or most likely, you'll be able to do the same kind of things I'm talking about here with Wireshark. But this is certainly the preeminent open source type product. So a basic Wireshark main view, you probably know all this. I find a lot of people use Wireshark at what I'll call its default operation. They open it up, they use it to gather packets, they find the magic packet. If they're the network team that says it's the server team's got a problem, or if the server team pointing to the database team's problem, you know, it's never my problem, right? It's never the network team. The network's never the problem. I'm hoping some folks are laughing, going, yeah, not my place. Anyway, we get blamed a lot, but it may not be our problem. But they use Wireshark in this default view, and that's quite all right. There's not a thing wrong with that. What I want to show you is a few little tidbits here and there that may help a little bit. So one of the first things I want to show is my Wireshark. I don't have the packet bytes view because for me it's visual noise. It takes up space. So it's really easy to just turn that off and get it out of your way. And we'll be showing you some of these things if you've not played with that before. And if you need it, when you finally found the magic packet that points to the problem, great. You can very easily bring that view back up and have that data and then close it out again. So I have a few things that are a little bit different here depending on your usage frequency of Wireshark. You might notice a few things that I've got different in here. I have some colors that aren't part of the standard Wireshark coloring rule definitions. I have some display filters up here on the display filter bar. I'm going to be talking. I've actually have a very set of special configuration profiles, and these are all the things that I want to talk about for the rest of our time tonight in IPv6 inside of Wireshark. So, first little section I want to talk about is the coloring rules. Now, this is probably one of those features of Wireshark that I find people have about the strongest preference. Some people love it, some people hate it, and some people it just doesn't matter. It's almost like I don't, quote, use it to any particular advantage. I see packets with colors, maybe I understand, and that's all fine and good. I use coloring rules, especially for all of my IPv6 stuff, very, very heavily. And I use it from the aspect that I want to see certain kinds of packets go flying by. I want to make sure that they happen. Maybe I want to, oh, finally I see the packet I'm looking for, and it helps me a lot from that perspective. And it kind of separates, especially now with v4 traffic and v6 traffic, it starts to help isolate my viewing of v4, v6 type traffic when I have to kind of leave it all on at that point. So colors can help you if you choose to use them, and I highly recommend it. If you set up and play with colors, one of the things you understand about them is that they basically operate similar to router ACLs or firewall rules in the fact that they process in order top down. So as you create coloring rules, like these top 4 here are my created, my added to. And initially they're put down at the bottom of the list, and so you kind of have to move them up the list in order for there to trigger. So in this case, I want, I had this backtrack computer on the network I was looking for. The other thing is here's this ICMPv6 type 134 is a router advertisement, got it colored orange. The type 133 is a router solicitation, meaning devices are asking, are there any routers out there? And then the routers would reply. And then I say, okay, after that, all the rest of this ICMPv6 traffic. That was quite fun. I was playing with this weekend, and when I created that rule, it's like I put it at the top of the list, and then I couldn't see any orange or pink packets anymore. Well, duh, right? It got triggered before my very specific ICMPv6 type components. So I had to play with that. You might actually notice down here a little bit further in the listing that there is an ICMP category, but it actually is ICMP for v4 as well as ICMPv6 traffic. And so if I didn't have this yellow ICMPv6 very specific color rule set up, all my v6 ICMP traffic looks just like v4. And that's just not the way I wanted things to be operating. So that's why I have some colors that's set up. So it's, as they say, relatively easy to set these up. And let me do this here. I'll bring it up in Wireshark, but just to kind of see it a little bit more closely here. Setting up colors is, quote-unquote, not all that hard if you know what you want to look for, and if you can start deciding on colors to use. In this case here, I was building the, quote, orange packet, you know, for the v6 router advertisement. It takes a little bit playing with the color sometimes to go through, but it's not, I would say, overly difficult. So what I'd like to do is switch over to my Wireshark right quick and just kind of go through a couple of things here for you. So initially I have, as the screen comes up here, I have my Wireshark set up in this case in its default configuration. And it's going to have its default coloring rules, its default settings. And again, one of the things that I'll do is just remove the packet bytes area. Is very easily just go to View and then deselect the packet bytes choice option, and then it just removes the packet bytes. And I've got more real estate now to look at the actual packets and the packet details as I want to. To play with the color rules is, again, relatively easy. You can either come up to the toolbar and just select the little palette, looks like a color palette with a hand, the edit coloring rules, and then you can bring that screen up. And I could build a color rule and say, oh, maybe I'd like to look at DHCP v6 type specific traffic or packets, and go ahead and put in the string variable. Now this is also basically the same as display filters, as I'll get to that in a minute. So I can build a color rule, and it put that color rule somewhere in here. Where to put it? Actually put it at the top. And it's still that same basic default blue. I can just as easy come over here and edit that, and we'll go to the background color, and let's just say we'll make that I need to make it a different color, like a pink green kind of color here. We'll try that, see what it looks like. Oh, I went the wrong way with it. It looks like background color. Oh, I changed the wrong thing. There we go. There, we'll try that color there. Not a great color, but it's a color. And so you can kind of see here, I've got, as it's on deselected, there's that new DHCP v6. So I can apply that color rule into my system. I'm not too worried about it triggering before any of these others because it's its own protocol. And I could go through and maybe see if I can see any of those colors pop through. And it gets a little hard. It looks like we might have had one in there somewhere. It's hard to say. The other thing I can do is I'm going to go ahead and put it in as a display filter and just see if I had any. I didn't actually have any. So let's do this. Release 6 and renew 6 so that I can generate hopefully a request for a v6 address. Looks like I got one, but I may not have. Oh, gotta have Wireshark running. Who didn't help me have Wireshark running? Oh, don't you just love on-site demos? They're just so much fun. All right, let's do that again. Release, renew. There we go. And there's some of my packets. All right. So if we clear that, now, it's one of those looking for some of those packets in the trace. It was really hard to find them in there, but we saw a couple of colors. If you look real quick in there, there should be kind of an orange one popping up here anytime, and somewhere they're in there. It's going to take a little bit too long to find them, so again, we'll just look for them. So, color rules. Lots of different things you'll see as some of my traces go through in here with the color rules. So that's one bit. Playing with colors. Now, one of the other options in here is columns. I use columns for all kinds of different things. Certainly if I'm looking for specific types of protocols, or I'm looking for certain functions or certain actions or certain text, whatever I might be looking for. But putting in columns is not a hard thing. One of the columns I've been using more and more over time now is the delta column, because I'm looking for those router advertisements, and I want to make sure that those router advertisements occur within the frequency that they're supposed to. By default, a v6 router interface should send out a router advertisement. Hello, here I am, I'm your router, every 6 to 10 minutes. You can tune those parameters, and I certainly do when I'm doing lab testing, because I want my router advertisements to occur more frequently. But I use that delta column. And it's easy enough to build some column data based on information that's within a packet, or you can manually build columns through the profiles or through the preferences editor. But columns are handy. I'll show you where I've got like the delta column if you hadn't already seen it. Now the display filters is what I use a lot of in Wireshark, and you just kind of saw me playing it in conjunction with the color filter, or the color rule. And display filters, or the capability of just, narrowing down the field of vision. You want to get less packets view in front of you, or see only certain packets go by, or only not see certain packets go by, as it were, in your troubleshooting or your testing scenarios. When you're typing out the syntax for the filter definition, when it goes green, kind of as this example here, it means it's good from the aspect of the display filter can function. It doesn't mean that you're going to get what you want. At least that's what I find myself. I don't always get what I want, but the syntax is good. If the bar up there, instead of being green, is red, Wireshark can't do anything with it. And if it's yellow, it's like, well, I think I can, but there might be more that you want to do as well. So filters can be your friend, especially if you're capturing all packets. Now, one of the other cool things about display filters, it's down at the very bottom here, is that you can save some of your filters, or any number of your filters, if you use certain ones a lot. And that just becomes a much handier way of using display filters to be able to bring in or take out certain types of traffic that you need to be looking at. Now you can manually type in filter definitions, and you can also effectively right-click in the packet's detail on virtually anything, any field within a packet, in the packet detail area. If you do a right-click, then you can go up and say, apply whatever you've highlighted as a filter, and then it can be, well, I want to filter on that, or I don't want to filter on that, or I want to add it to what I already have, or I want to OR it. You can basically see the logic to it here. So if you're trying to build a display filter on, say, a DNS query, and you keep, what I do, messing it up, right? I keep getting the wrong information, so I'm not displaying what I want. Just go down there and right-click, highlight it, and make your filter from this perspective, creating your filter from the packet information itself. It becomes a much easier way to operate, I generally think. So, a couple of ways to do that. Set those up. In Wireshark, there's 3 predominant families for v6-related filter definitions. There's IPv6, which is inclusive everything. There's ICMPv6, which is just that subset, and there's DHCPv6, which is that subset. And you can go see all the different ones at the wireshark.org site. So we're kind of seeing a little bit here. In this case, I have an example display filter of all ICMPv6 or any DHCPv6. You would type it in, the bar goes green, and then you would click the apply button and filter out for just that type of traffic. So what you end up getting is something likened to this, and like what the example I just showed a while ago, where the colors can stand out. I'm filtering for very specific types of traffic as well, and I can very quickly ascertain, what's going on here. You can even see I've got the, over here in this example, the delta column, so I can see these router advertisements that are coming through, all these orange packets, and I can see the frequency, although I didn't have the column opened up wide enough. But lots of information, even though this is a very small subset. Based on my filter, I'm looking for router advertisements and just DHCPv6 type traffic. But you can see all the things here. Router advertisements came out, the client went out and did its SAR process with the server, it got its address, life was good. So let me break into my Wireshark again and kind of look at this. So we can see here that I had initially been playing with a DHCPv6 filter. So one of the things that I can do right quick is, since I like this and I know I'm going to use this a lot when I'm troubleshooting IPv6 or validating an IPv6 operation, just come over here and click the Save button, give it a name. I'm going to give it the name of what it is, DHCPv6, and you'll see that that name pops up on the filter bar here in Wireshark. So if I clear that display filter, so now that I've got all my my v6 traffic visible to me. And it's one of those things, well, did my client or clients ever ask for a DHCP-v6 server? Did they ever try to go out, and did the server reply? Did everything work? Well, you can very quickly just trigger on that filter. And you can see the packets are still kind of counting up down there at the bottom status bar. We're not going to see another one of these until, in my case, I'm the only client on this network. I'll release it and renew it again, and then we should see another set of processes, and we do. Now let's look at another type. ICMP v6 dot type equal 134. I want to look for router advertisements. And so you should be able to see in the screen coming up all these orange packets, and these are all the router. And oh wait, I don't have a delta time column over here. This is my default profile, so I don't have anything special. Well, let's go put that delta time column in right quick. So edit, and then preferences, and then we'll come up here to columns. The screen updates just about there. I'll click on columns. Now actually I have one, but I'll go ahead and create one. I'll do an add. We'll call it Delta. We'll come down to the field type area, and I want Delta time displayed. And it's going to put this new column all the way to the right on the other side of my information column, and that's too far. I want it over here up by my packet number. So I'm just going to drag it and move it up here into that order, and now it will put in that new column for me. And you can see the delta time column now over showing up between the number and the time. And now you can see the timing between each of these router advertisements. So I see my router advertisements. I saw my client get addresses. We kind of knew that anyway. And I can see how frequently these router advertisements are coming up. And I want to save this particular filter as well. And I'm going to call it IPv6 RA for router advertisement. Now in this case, for the environment, a router advertisement and DHCP-v6 kind of go hand in hand. So I'm just going to modify my existing DHCP-v6 filter definition, and I'm going to say I want to see any router advertisements or any DHCP-v6. And I'm going to apply that filter, and now I can see all these things together, and I'm going to save this filter, and I'm going to call it RA and DHCP-v6. And so you can start to see how all these filters add up, these display filter definitions. If you keep going and you have more than you need on the line, you just get a little drop-down box at the far end of the filter bar, and you can get the rest of your display filters. So the power of using display filters and coloring here is that I can much quicker find the certain types of traffic that I need. In this case, let's just look at all IPv6 traffic. And now we can see, I'll let this trace run a little bit. You know, we've got some v6 over web. I had some SNMP over v6. Here's some OSPF packets. You know, so we've got all this v6 traffic that's actually occurring on this network segment that I'm on. But yet, sometimes I want to see, you know, something else. In this case, did my router advertisement come out? Did my client get an address? You know, this or that or the other, if I wanted to look at certain things. So lots of horsepower. I could even go ahead and we'll just save this as a filter and call this IPv6. So, you know, now I'm building up these components. Now, with all of that said, there's one more specific feature function I want to talk about here, and it's known as the configuration profiles. So I want to go back and bring up a slide real quick to show that, and then I'll show it up in Wireshark. Configuration profiles are an awesome tool used in Wireshark to allow you to manipulate between different, I'll call it configurations of use for Wireshark. Meaning, if you're troubleshooting IPv6, you can have a whole set of characteristics that represent things you need to have available to you, your display filters, your special color, your special layout for Wireshark. If you're troubleshooting your specific applications inside the network, you may want a different configuration profile that has different columns, different colors, different display filters, so that you can very quickly maneuver through the packets from that aspect. That's the not the horsepower, but the big power, really, of configuration profiles is being able to retask your Wireshark presentation. So you can build these as you go, you can copy them, you can do all kinds of things, and the best part about them is they're portable. So when you've got a configuration profile with display filters and color rules and all those things defined, you can save that. It's a folder with about 5 or 6 files in it, and save it up to a shared drive. Make it available to other members on the team. Make it available to all your other computers. You know, if you're like me, you probably have 2 or 3 computers at least that have Wireshark on them. And every time you move around, if you do any of this kind of work, it's always one of those, where's this filter? Where's this configuration? Put them up on a shared drive every time you make changes, and you know, download them to your Wireshark again. So this is how you can use the different configuration profiles to your advantage. And so let me show you a little bit more about that here in Wireshark. So right now I've been playing with this default profile configuration or profile definition. The very bottom right side area of your Wireshark screen in the status bar is the profile config or profile option box. If you just simply click on that, you can see varying profiles. So I've got the default, I've got all these other ones that are set up slightly different. If I click on this Jeff main, it'll come up, and it's actually going to have a somewhat similar view here, but it's not going to have, it doesn't have the same display filter setups over there. And this time, if I click on my IPv6 packets, you'll see they're not that orange type color. They're the standard default because I had the color rule as part of that other configuration profile. I've got all kinds of, you know, again, different capabilities up here in my my display or my filters bar, display filters bar. Even if I want to look at DNS type traffic, and you can again build these things for different functions. I've got one I call QoS, and it's actually kind of my standard view, but I used to have, it looks like I may have taken it out, but I used to have a column that would just show me my DSCP or QoS values. I have another one in here that I would use for some special workshops, and I had all kinds of different columns in here, different display filters, etc. So this becomes a lot of the capability of these configuration profiles. Again, you tune your Wireshark view, your Wireshark operation to very specifically what you need to be seeing for that exercise. Again, I've got some up here, a little bit different definitions in the display filter. Again, my color is not set the same. So this is one of those, when you tie these other configuration capabilities, the coloring rules, the display filters, your panel views, whether they're vertical, horizontal, which ones you want, you can tie all those together, bring them into that profile, and then to navigate to them, if you click on the Help button and then go to the About Wireshark and then click on the Folders tab, as this all comes up here, all of these profiles are kept in a folder, and all you have to do is go grab these folders, and you can see this IPv6 folder has got these particular definitions. So I can simply copy that folder off, I can make it available to the team, I can email it, I can put it on a flash drive, whatever, put it in that same Wireshark profiles folder, and then when you fire up Wireshark, there's everything that you need. And so if you're working with the different teams, if you're part of network and you're helping server and you've built a special configuration that would help them with their Wireshark use, there it is. It's a profile that's portable. So I strongly recommend that folks use these capabilities, these I'll call them extra capabilities of Wireshark, when you're troubleshooting or just anytime you're using Wireshark for anything. It doesn't have to be IPv6, of course. You know, it can be any of these things. So one of the things that I wanted to show next is kind of this additional combinations of stuff. I've got a couple of computers that I have access to, and I want to show you a couple of different things that change in kind of this v6 operation and how you might be seeing things with Wireshark. So the first thing, I've got a computer here on a network segment, and you can see it's v6 addressing. It's in the 2001:470:VA40 is assigned to me by my provider, and so that means I've got a 48-bit network prefix assigned, and now I have another 16 bits that I can play with for all of my my own networks. And I actually break it up by these nibbles to say it's network 1, and then it's G means group, or 6 means G for group, and then the third nibble in this fourth hextet is the VLAN, or the network, and then the fourth nibble is the VLAN. So it's VLAN 2 out of that network. And it's a little bit of work, but it's a lot similar to things that we've been doing for years in our different addressing. So we can see on this network with Wireshark running, we've got the router packets going out and about. We see these renew reply DHCP messages, which probably indicates that our client's addresses have timed out. And you can see over here in the breakout of my local addresses, my timers. And I'll run it again just so we have it. And you can see that this global unicast address up here has, at this time, valid lifetime of 4 minutes and a preferred lifetime of 2 minutes. It's a DHCP v6 derived address. And then you can see my link local self-assigned address has infinite timers, because it's just that. You know, the timers are good as long as that interface is activated or plugged in or turned on, whichever way you want to use it. And these router advertisements go out. We can kind of come back here and see that these are occurring. Here's 27.5, almost 30 seconds, 18 seconds. So one of the quick things to look at is to see, oh, my thing disconnected. Whoops. Is how often these particular addresses are supposed to occur on this particular network. And I think I need to go to, sorry about that, I had these up, but they timed out on me. Oh no. Rats. Well, hang on, we can see it right here. I need to go to it anyway, but this VLAN 2 is the client's. You can see this network prefix, 2001:470:VA04:1612, that matched what the client has, and then this address is : 254. I have a helper address for v6 to go to my DHCP v6 server. It lives on a different VLAN, VLAN 1 in this case. And this router advertisement goes out every 20 to 60 seconds. And I'm telling the client that you're not going to get your network prefix from me. You're going to go ask a DHCP v6 server, and I will point you to that server. So that kind of has all of that information that's going out. If we go over here and look at one of these router advertisement packets, and let me move the screens up just a little bit here. Can't quite grab it. Then we can see that even though we have a network prefix going out, we're not telling it to do the Slack function. We are instead saying we have this particular flag, the M flag, known as the managed address, which means go ask a server. And so that's what the client does every time that it gets one of these router advertisements. If I change the behavior of those particular router interface configuration options, then our client will operate in a different mode. So let me swing over right quick and see if I can't get that resolved. I apologize. I thought I had this all set and going, and apparently I did not. So let me set this real quick. There we go. Now I've got to lock it or unlock all my connections here. Sorry about that. Clear line 35, yes, and 36, yes, and open that up. You might even notice that I'm actually communicating to a telnet or to a terminal server, as it were. It's actually a Cisco 2651 over v6. So if we look at my users, this one's local. Oh, I selected the wrong one. I've got so many different things here, so we'll get to the right one. I need 36. All right, show telnet. Oh, I'm communicating to the telnet server, not to this guy. All right, one last thing. Show users. Show users. Everybody's probably over there laughing. Okay, now you can see I've got all these v6 connections. So it's another way to show v6 is working. All right. So if I look at this, it's an HP ProCurve switch. And if I come in here and make the following changes, I'm going to say I want to use Slack operations for this client. I do not want to use DHCP v6 options. Then I will take out the M flag and I will put back on the A flag. We'll come over here to our Wireshark traced and we'll pick up one of these fresh screens, and let's do a make sure I got that going. Sure. Okay, so we should have the A flag on, the M flag off, and let's go find a fresh one, and there we are. So here's the M flag is turned off in the router advertisement, and the A flag is turned on. And if I come over here, I will now have a different set of addresses for this interface. I no longer have the DHCP v6 address. I now have addresses that the client derived the network prefix from the router advertisement and then added in this case, Microsoft Windows by default uses the privacy extensions or the random number generator process to generate the last 64 bits. And I can still get to the outside world like I want to, and life is all good there. You see I'm pinging Google.com here. One of my other favorites is pinging Facebook. It's a great example from the aspect of their network down in the 5th and 6th hextet have Facebook in hex. So a lot of entities are doing that. Again, I wouldn't do it in the network. Down in the last 64 bits where you can kind of play for the host IDs, it's a great place to maybe spell words. But still, you got to be a little bit careful in doing that. Now, if I come back over here and retask the router messages to go back to saying I don't want to do DHCP or do want to do DHCP v6. I do not want to do Slack anymore. We can kind of see that config. We'll come over here and look for a fresh router advertisement. There we have one. Nope, still not fresh for us. Still kind of right there. We go, oh, here's my problem. I didn't have that selected. And so that was probably one of them right there. So now we're back to the M flag is on. The A flag is off. You can see how easy it is to find those router advertisements. It's easy enough to find the different protocols that are going on. Now I am looking at a more limited subset of all the traffic. I'll just clear that filter right quick and you can kind of see all the different traffic that's going on. I've got my RDP session, that's all this V4 traffic. that I'm doing here. So that kind of takes away from a little bit of what's going on. And so we'll kind of go back to IPv6. Oh, here's a little thing over here. You can see my display filters go further than my screen, so I've got a little drop-down arrow. I can look at, just filter out for all of my quad A records and replies DNS type traffic. And what's really interesting is there's a feature in IPv6 known as Happy Eyeballs. Go read it. It's an RFC, and it basically says that if a computer is v4 and v6, or just even v4 only, it will actually ask for DNS resolves with both A and AREC requests. So in this case, it's sending out, even on v4, it sends out a quad A request. And even if the reply comes in, as we'll see from our DNS on v4, that even though it's all v4 transport, it's related to v6 information. So if this client is v6 enabled, I can get to it from either v6 or v4 as far as the resolve information, the DNS resolve. I may even have some other technologies known as NAT64, DNS64, where I'm v4 only, but I could still, with some of those capabilities, the transition mechanisms they call them, get out to a v6 world. All right, so different little things that are going on, different functions of using display filters, using coloring filters. We can see here in this entire trace, I've never had a router solicitation, but we've had lots of router advertisements. Another feature or function that you might want to use that came out in Wireshark 1.8 is known as the packet annotation, or packet comments. So I could sit here and right-click on a packet and say make a packet comment, and I can say that this RA has M on and A off for stateful ops. And I highly recommend that you do these kinds of things as you start playing with v6 and looking at the different packet types, and you're building your library of knowledge to go into a trace like this and say, make some comments. We can make another comment here just for grins to say part of DHCPv6 renew process. And now you can very quickly build a filter known, it's already a predefined, as PKT for packet underscore comment, and go through and find all of your packets that have some kind of a comment in them. And this is great for any process. It doesn't have to be v6, of course, but it's really handy. And anytime you've got a trace file that you're trying to make available certain information to folks, or for yourself, reference information, if you're troubleshooting and you have, quote, a bad trace, go in there and make notes about what's bad about it. And then when you get the good trace afterwards, go in there and make notes about what's good about it. And then that way you'll have that reference information 18 months from now when you have to do it again. Make this kind of stuff when you're playing with IPv6 in the lab. And then when you start rolling v6 out into a production mode, you can refer back to the lab testing scenarios and now get traces of the implementation side and determine, are you seeing the same things? Are you getting the same types of information? Are the packet flows relatively similar? And those can be really, really handy. So it's another small feature of Wireshark that not a lot of people know about, but it's just an awesome, awesome feature that came out. Was very much, very widely applauded when they started this packet annotation feature. It was in Wireshark 1.8 or above. I highly recommend, if you're not at least to Wireshark 1.8, go get it. I'd recommend now, they just came out with 1.12 about a month ago maybe, and it just keeps getting better and better. And they're coming out with an even completely new user interface that's going to be common across all platforms. So if you've used Wireshark on a Mac, it's a little bit different as far as its layout and operations and stuff compared to Wireshark on Windows, Wireshark on Linux. They They're all slightly different, but soon that's going to be changing. There's all kinds of information you can read up on that. So that's, real quickly, some things about IPv6, if you haven't seen it or heard it before. There's some information about, of course, just basic Wireshark, and then kind of bring them all together. When you start playing with V6, you should fire up Wireshark all the time and be looking at the traffic and looking at the different things that you're seeing and making notes to yourself about what you do see. So the last little bit that I'm going to show here is some references of different books, different publications from different folks that are out there. Of course, all the Wireshark related type information, just TCP/IP in general, IPv4, IPv6, lots of Wireshark traces in that Guide to TCP/IP book, Laura Chappell's book, just awesome amounts of information, a few more per projects that she's published out there. Some other good books as well. If you're studying for the Wireshark certification, there's a good exam prep guide. It's just also a great reference by itself. Chris Sanders' Practical Packet Analysis book is another good resource for information, similar, kind of between Laura's 101 and Advanced book. It kind of fits in really nicely there. A couple of good references on IPv6, really, really fresh. There's one on address planning that Tom Coffin is putting out. It's almost finalized. They've got it in an early release mode. Just a great resource to learn about address planning in V6 and kind of just using the addressing stuff. An overall good rounded book for V6 is Sylvia Huggins' latest update, IPv6 Essentials. This just came out about a month and a half, maybe 2 months ago. But a great, well-rounded, and now update book. A couple of other books on V6. IPv6 Fundamentals by Rick Graziani is a great, also foundational book, and it has a slant towards a Cisco environment. He's a professor at a college in California, as well as teaches Cisco courses, so it's got a great reference kind of view that direction. And Ed Horley's book that came out at the end of last year, right before Christmas, like hours before Christmas, is a good book on V6 and a heavy focus to a Windows environment, using not only GUI configuration capabilities, but the PowerShell, all the different PowerShell options from both the servers and clients' perspective of how to get in and manipulate, configure IPv6 in that kind of environment. So with that, thank you very much. I'm so appreciated everybody came, and if you have questions, you can ask them out, you could tweet them out, you can follow up later. The session is being recorded, should be out in about a week, and I will have this slide deck available at that time when they publish the recording of this podcast, and you'll be able to get access, again, just as a little bit of a reference. So with that, I'll turn it back over.
Awesome. Thank you, Jeff. Any questions for Jeff? Feel free to tweet at vBrownbag, the hashtag vBrownbag. Send us a question within the GoToWebinar interface. Let's see. Joe and James both say thank you, so thank you, Jeff. Also, if you have any questions for Jeff outside of the podcast, feel free to tweet him at Jeff Carrell _V6. JEFFCARRELL _V6. So, yeah, I'm not seeing anything here on Twitter. I think it was, I think you covered everything.
Great. Well, my pleasure.
Yeah, absolutely. All right. Well, I guess that covers it for the evening. Thank you very much, everyone, and we're looking forward to seeing you guys next week, Wednesday, September 17th at 7:30 p.m. Central.
Awesome. Thanks, everybody.
Yes, sir. Thank you, Jeff, and thank you, Ahmad.
Sure. Yep. Thanks, Damon and Ahmad. Appreciate it.
All right. Good night, everyone.
Good night.